So to start the process, to begin to think about future generation options and how we looked at the methodology around that, I'd like to introduce Mr. Rob Petrolak, the Managing Director from Black & Veatch. Thanks, Rob.
Thanks, Tim.
Thank you.
Thank you. Well, good evening, everyone, and welcome. As Tim said, my name is Rob Petrolak. I'm a Managing Director at Black & Veatch in their Management Consulting Division. And I lead our energy markets and resource planning practice area. And so my team and I have supported or worked with OPPD on the analysis that we're going to talk about tonight. I'm very pleased to be part of OPPD Listens. I think it's a great opportunity to exchange and communicate with all the stakeholders that are involved here in the area. And really in the next 20 minutes, I'd like to review the methodology and the approach that we used. I believe that what you're going to see is it's going to demonstrate really OPPD's commitment to its customers to have a very robust and transparent process. So let me, before I get into that, just talk a little bit about Black & Veatch. Black & Veatch is one of the largest engineering and consulting firms in the energy sector. We touch just about every part of the business. We're recognized by our peers as well as publications, and so we've gotten various awards. We also primarily do most of our activities or engagements are with electric utilities. But like I said, we work really across all sectors of the business. I put a couple examples of some recent resource planning type work that we've done, and just so that you get an idea of some of the customers we work with. My team works nationally. Obviously, we've done a lot of work here in Nebraska, but we also do work all over the country. The process is pretty much the same. We make some adjustments based on the data and based on the regions, based on the input from stakeholders. But realistically, the process is designed to be transparent and robust and to be helpful in helping utilities make strategic investment decisions. So let's talk a little bit about the methodology and approach. So first of all, when you do resource planning, the underlying objective is to have the right balance between system reliability, fiscal responsibility, as well as environmental stewardship. That's very important, and it's the basis of what we would refer to as an integrated resource plan. Keeping that in mind, as we approach this analysis, we kept that as a foundation. And basically, in this particular analysis, the purpose is to look at OPPD's future resource options and look at what opportunities are out there for OPPD. As far as the objective of the study, we're going to be evaluating, and we have evaluated the risks of various combinations. And when I say combinations of resource options, what I talk about, or what I mean, is supply and demand side resources. Supply side resources could be new generation. It could be combined cycle plants, combustion turbines. It could be wind. It could be solar, et cetera. When I talk about demand side management, okay, that's where we look at conservation, energy efficiency. We look at demand side programs that could reduce demand and help lower the requirement that OPPD has to meet in order to meet its reliability obligations with SPP. We also, as part of these portfolio or resource options, we look at retrofitting and refueling to complement the replacement and the reducing. We also look at market purchases. Participating in SPP allows OPPD the ability to purchase from the market when it makes sense and when it's cheaper to do so. And OPPD will do that, as every market participant does. So really, if you think about the overall methodology or the approach of the analysis, we basically are evaluating these various resource options or plans against projected energy market prices. And we look at that under multiple futures. So we're going to talk a little bit about that right now. Now, when you develop the different market futures, the scenarios often referred to, there's a lot of issues or assumptions that you need to look at. And you need to look at these in an integrated fashion. And of course, OPPD has done that, and I'm going to talk a little bit about that. But these are just some of the things, the integrated issues that need to be addressed. Regulation, RPS, demand. I'm not going to go down through the list. You can see them, but there's quite a few things that take into consideration. So this slide depicts really the environmental regulations that are out there. They're the key ones that are out there in the marketplace. And it's really because of the compliance or OPPD's desire to comply with pending or potential EPA regulations that we're really here. We need to make some decisions about the coal plants and how the future of future resources for OPPD can be complemented by that. So when you talk about generation resource options, I mentioned 4 R's, right? Retrofit, replace, refuel, and reduce. Let's talk about retrofit and what that means. So retrofit is about focusing on the existing plants, the existing coal plants, and looking at environmental control technology or solutions that can allow those plants to meet the proposed or potential regulation in the future in order to keep them running. And so there's a list of different technologies or solutions there. And what we've done is we've looked at all those as part of this process. The next one is refuel. So another way to approach meeting these regulations would be to refuel, to actually convert from coal to natural gas. Natural gas cuts carbon emissions by 40%, and it minimizes mercury, NOx and SOx emissions, which is targeted under some of these regulations. Replace, I've already talked a little bit about that. That's the idea of you'd retire the units and then you would add new units, which could be combined cycle plants, combustion turbines, solar, wind, etc. And then I talked about reducing, and we're going to show a slide here actually right now. We're going to show a slide. When I talk about reducing, you see the green line. If you look at this chart, there's a red bar that shows basically OPPD's existing resources. We have at OPPD just under 3,000 megawatts of capacity that's available. The green line represents the total reliability requirement that's required in order to cover its peak demand plus a reserve margin. And this reliability requirement is required by SPP. And so OPPD's responsibility is to make sure it has enough resources in order to meet the requirements of reliability. So if you looked at this and you say, well, hey, OPPD has enough resources until 2023 to cover that green line. And that is true. But what changes the picture is the environmental regulations that come into play in 2016. So what happens in 2016 is OPPD's got to make a decision. What do we do in order to comply with this future regulation? And so what we do is when we do this type of analysis, we basically, in 2016, take out the units that don't currently comply, as is. And then what we do is we start building portfolios, combinations of demand-side management, supply options, and retrofit and replace. We start combining portfolios, and we look at, we try to optimize and look at which portfolios meet that criteria, but also perform best under various futures. So I'm going to talk a little bit about that, but the reality is system reliability is the most important thing, or among the most important things for OPPD. But when we do this analysis, we're trying to balance. We're trying to balance the environmental benefits, the cost benefits, and also reliability. So when you look at the different technologies, the different types of generation, this chart kind of helps us kind of put things in perspective. At the top, I characterize as intermittent resources. The bottom is capacity resources. Intermittent resources could be wind, it could be solar. There's some other, other ones as well. But when we talk about replacement of the capacity at North Omaha or at Nebraska City, intermittent resources are not available 100% of the time. And so we really need to focus on capacity resources on the bottom that can actually backfill and fill that gap to meet that reliability line that we just looked at. And so that's how we have approached this analysis. Now, you might say, so there's a capacity need and then there's an energy need. And you're going to hear a little bit in a few slides about the benefits of intermittent resources and how OPPD uses them in order to serve its energy, but it doesn't eliminate the need for capacity. And here is that slide I was just talking about. So renewable resources. OPPD has a voluntary renewable goal of 10% that should be achieved by 2020. Now what you see here is in 2014, you can see that OPPD right now is at about 16% with its existing renewables that it has on the system. So this is part of the mix of how it's serving its load. 16%, roughly, I'm eyeballing that, 16% or 17% of load is being served by renewables. Now you see it go up in 2018. Well, OPPD has made a decision to enter into power purchase agreements for Prairie Breeze as well as Grand Prairie. Those agreements will come into play, those plants will be built and come into play in 2018. You're going to see that OPPD is going to be over 30% of its energy is going to be served by these renewables. So I guess a couple things just to point out. Number one, OPPD is going to well exceed its 10% goal. Number two, which I think is important to point out, is when you look about renewables portfolio standards across the country, right? The most aggressive renewable portfolio standards in California. They have a target of 33%. You see that OPPD is actually going to be at 30% or above 30% by 2018. It sets OPPD really as a leader in this its pursuit of renewables. And so I just want to point that out. The next slide talks a little bit about how we develop the market prices. I mentioned that we need to talk about or develop market prices for SPP. This is just a depiction of how Black & Veatch does the integrated outlook for market prices. And what we do is we have to incorporate world and U.S. environmental policies. We bring in a lot of fundamental models looking at oil, where gas prices are going, coal prices. They all need to be integrated because everything is related and correlated and needs to be integrated. And basically, we develop a view for North America. And as part of that, obviously, we pull that sliver of SPP, and we're using it in this particular study. So that sets the market prices that we're going to use. Now, the way that we do the modeling, and I just want to give you an idea of how detailed it is. So for 20 years, every portfolio that we take a look at, we look at a 20-year period of time for that portfolio. We look at it hourly. The market, the model actually simulates on an hourly basis, looking at all the parameters, the characteristics of the generation, and it dispatches just like the SPP market would operate. And it determines how much that generation runs, how much revenue it gets, how much it costs. It determines how much emissions is going to be emitted. It does a lot of detail. And so that's how we gather the information that I'm going to be talking about in order to evaluate the benefits of the various portfolios against each other. So this shows you basically the energy price projections on an annual basis for the 4 scenarios that we had. So, in this particular analysis, we have the portfolios. We run them not only against the Black & Veatch case, but we also run them against other scenario products. We've chosen to use scenario products that are commercially available and are developed by consultancies that are well known and have a great reputation in the industry. So this particular case, these are the CIRA scenarios. And so they have, basically you see 2 cases that are kind of in the middle. They might be considered the 2 base cases. And then you have 2 outer cases, so that you can, when you run the portfolios against them, you can anticipate or be able to analyze how they perform under different potential futures. So the high one is our green case, our very green case. The low one is more of a economic downturn, and the middle cases are more realistic. So that's kind of how we do it, and I think the optimal goal is to figure out which portfolios perform best, not only under the green case, not only under the down case, or not under the base case, but the ones that perform most robustly over all 4 cases. Because diversity is very important, and with gas prices changing and the challenges for nuclear and different things that are going on in the industry, the regulation on coal, you're starting to see a lot of talk about, changing of the mixes. Black & Veatch, my outlook at Black & Veatch, our energy market perspective, projects 60 gigawatts of coal retirements by 2020. And so when that comes out of the picture, what that does is it starts increasing the amount of natural gas and renewables, as far as serving energy. And so as you start pulling that out of the mix, your diversity starts going down. And so, I just want to point out that diversity allows you, and I've seen it. I've seen boom and bust of nuclear. I've seen boom and bust of gas. And we've seen it. And one thing that it just seems like in this industry is very difficult to predict the future. New technology comes in, turns the whole world upside down, and everyone starts scrambling. So the value of diversity is very important. So as I mentioned, those were the 4 scenarios. We run our portfolios against them. We pull a lot of data down. This is an example of the net present value of total system power costs. So we looked at a large number of portfolios. We basically shrunk it down to a more sizable, hey, these look interesting, and then of course you size it down until you make a decision. So this is an example of some potential output of the different portfolios and how, on an NPV basis they match up, and it breaks down the costs of these things. So you have all the system costs, financing, fuel cost, environmental costs, and it's broken down. We can pull that because of the very detailed model runs that we do. So that's one performance metrics that we look at. Now the reality is we don't just look at one performance metrics. It's not just about cost. Cost is very important, but again, going back to the triangle. So we measure, the total system cost. We look at environmental costs, obviously sales, purchases, how much is going to SPP. We want to know what that is. We look at how much gas is burned, how much coal is burned. These are all things, how much CO2 emissions, NOx emissions, SOx emissions. So if you want to summarize kind of our process, step 1, you run the models, you run the resource options against the scenarios, the futures. Step number 2, you extract all the data and you put it into scorecards and you start looking at comparing the different portfolios against each other. Step 3 is we go to our stakeholders, we go to our customers, and we talk to them. We tell them about the process, we tell them about why we're making these decisions, what's driving the decisions, we tell them how we're looking at it, how we're thinking about solving the problem, and then we ask them what's important to them. Some of the things like affordability, emissions, fuel diversity, trade-off analysis, etc. And so that's really, in a nutshell, the process. Now, once you get all that data, and you're going to see some of these cards around the room and at the satellite locations, I believe there's packets that are handed out. But what you'll see is we've summarized these on storyboards. We have the schedule that's identified basically what would be going in and what would be going out for a particular portfolio. We summarize the benefits to emissions against the base case. So you can see, based on what existing generation is today, if you use this portfolio, what's the reduction in carbon emissions, mercury, SOx, NOx, etc. We also look at what's the impact on the bill. So there's a piece of this that addresses what's the average impact on the bill. Then we also measure the total cost of implementing that particular portfolio. And then across the bottom, again, it's very important to understand what's happening with diversity. As diversity goes away, risk enters the picture because, you know, again, technological changes can actually change and you can find yourself in a bad position. If everybody bet on gas or bet on nuclear or bet on coal, there potentially could be problems in the future. So the bottom portion of it will show you at different timelines what is the diversity. So that ends really the discussion on the methodology and approach.